Hello, my name is Vadim Epstein. I'm a digital artist and creative director of Invisible Studio. Uh, I will briefly show you my showreel first as a kind of self-introduction. So recent 2-3 years, I guess 3 already, I use mostly neural networks to create visuals. I mostly do visuals, as I said, and as the most quickly developing, promising perspective and generally most interesting kind of techniques and approach in general. Before that, for quite a few years also, I was using also algorithms and code to create visuals, so-called generative stuff, which is characterized as that you're not painting it drawing in Photoshop or by hand, but rather create using code, and therefore you do not control it as much as like standard approach does, but it allows way more flexibility and way more interesting effects and results. And neural networks in that sense were quite a nice addition. For our visuals, we applied, we used them as just as a content for, I don't know, music videos. We did quite a bunch of video mapping projects, projecting and mapping stuff on every kind of buildings or objects or models or whatever. We were doing also, of course, some interactive installations, combining high-tech visuals with all kind of tracking or interaction with spectators. We were and are doing a lot of real-time performances as a VJs. That was my backend, and I don't know, that's where I'm originally from. I also used quite interesting objects and surfaces for our projects, combining video mapping with VJing, for instance, like we're doing live performances on the buildings, or also using some other things like neural networks, lasers, whatever techniques which are suitable went for that. They were quite interesting like objects to work with. This is, for instance, the wall of old city of Jerusalem. 150 meters of old wall was used as a surface at some live festival. This is somewhere in Brazil, I guess. I wasn't there. I only created some content for that. But okay, there were quite a bunch of really interesting projects. But let's get to the point of today's talk. So first, a few words about what is most interesting for me in AI visuals, in visualizing neural networks. Of course, we can just use some hallucination of neurons with the Lucid library, even export it as a shader to use in for real-time installations or other stuff. We can use some big GAN to create some imagery, also quite nice sometimes and definitely funny. But the point for me was that I was always trying to distinguish, to separate the content and the visual effects, so that we can use whatever imagery as a meaningful part and process it by some other effects to apply the form and the shape to that meaningful part, so that it looks really nice. So I was mostly interested in not creating visuals from the scratch. Of course, it somehow happens, but The process of creating visuals and processing them was always kind of separate things for me, like grabbing some imagery, static imagery, and process it in a way that it flows like liquid, like in this case it's animated as a forest shooting. That's why I was of course interested by GANs and stuff, but much more was interested by all kind of transformations, starting from, for instance, style transfer. Let's get first to that as a like kind of originator of all these techniques. So as you probably all, or most of us, or most of us and most of you know, the style transfer just was originally with transferring the features of so-called style content, style image to content image, and originally it was done frame by frame, was taken huge time to do that, and also required techniques like optical flow, like here, to make it smoothly, not as stroboscopic, where every frame is different. Then came obviously more like recent, more modern approach where was style transformer subnetwork was added to stylize any image, and style prediction network added to stylize any image with any style image, and that was quite nice, because it became nearly real time, or really real time, but the quality obviously was spoiled a lot. So it was kind of stylized, but comparing to the previous sample, you see the difference is huge. And also for like having one model per one style was not good. So then with those style prediction network, we could use multiple styles and smoothly lerp animate between them. This piece, for instance, is made as a feedback with feedback approach, so that it started with a black frame, and then every frame is used as a source for next frame with ever-changing styles, also taken partly from the previous frame, partly from some other set of style images. So these visuals are much nicer than previous. And if we add some content part to it, for instance, some building mask, we can use these in video mapping, for instance. So this is the project for Lille video mapping contest, quite successful, where the building was, the projection was animated with the same approach as previous video, but adding that building mask. Looked nice for the time especially, but you can see it once or twice, then it would become, I guess, quite boring. Next piece, a really nice piece which I found of Mr. Xavier, sorry, don't remember his really nice French name. He called it synthetic textures. It didn't really, it took care of content somehow, but it took much more care about stylizing. It used complex pyramid approach to handle much more complex styles, and it also used Riemann mathematics, like lerping all these styles not by straight lines as in Euclidean geometry, but on the hypersphere arcs as in Riemann geometry. So, and the result, the visuals were, as you see, quite impressive. It really looked as a fairy tale. And again, just mixing it with some building masks, we could use it as kind of video mapping technique, and just feeding to the same setup, feeding different start images, different building mask. You could repeat the very same video mapping on the different building, which is quite, by the way, is quite a serious, quite a nice approach. Because usually video mapping is supposed to be really site-specific, really fixed to the specific architecture, object, geometry, whatever. So having some technique which allows you to do the same or quite similar things with totally different objects, that approach was really modern and really nice. Then came GANs, generative adversarial networks, and things became obviously way more interesting. So first, obviously, it was just paired techniques which required preparing data sets, which was quite boring and took quite some time. Despite the quality was quite good from the very beginning, but obviously hardly it could be considered as a really production tool for various use cases. Then followed the quite huge portion of various unpaired architectures, started from the famous StarGAN2, which was kind of pix-to-pix, but unpaired and able to transfer there and back from A to B, from B to A. But on reality, in practice, it looked as a kind of style transfer, not in the best way. Style transfer could sometimes produce way more interesting effects and visuals comparing to, for instance, StarGAN. Some other techniques and approaches, like You Got It, which started to handle shapes, not just textures as StarGAN, but also really changing the macro features of the content. It was nice, but it was still stuck to the single domain, or at least single direction between a pair of domains. Then Unit, which also handled a single pair of domains, but was already multimodal. So within one domain, you could really learn quite a different modality of the output result. And also, what was quite nice, you could use also real images as a reference to process some other input sources. Another example of the same approach was DRIT, D-R-I-T, which was more or less similar to Unit. The difference was quite cosmetics in practice, I guess, as far as I remember. Then was FUNIT, which unfortunately, like for previous networks, I managed to train to test on practice. I was impressed by the time, but they also were not so practical because of low resolution, because of hard to training and stuff. FUNIT, like few shot unit-based approach, I didn't manage to train at all. Okay, I trained it, but it was tiny resolution and not so good quality. Then what was a really nice point, really nice architecture called MDMM, which meant multi-domain and multimodal. It really worked that way, so you could translate one image to various domains and have some also latent space of modality within one domain. But it behaved mostly as kind of, I don't know, StarGAN again. The best you could get from it were kind of subtle stylization. So like drawing the same shapes with some other colors or some other, I don't know, brushes, whatever. So that was better than nothing, but still was not enough. And then eventually the StarGAN2 appeared. So StarGAN2, under the hood, it had the idea, concept, philosophy, general structure a bit similar to the famous StyleGAN, which was quite revolutionary architecture in the pure GAN generation. We see here as well kind of mapping network and style encoder, which means that we can encode into latent space some styles and some quite extensive and diverse features. And then from that latent space we can generate quite also diverse and nice looking imagery. And so the result was also quite impressive. So it really handled the source, and it really produced nice result. This one is rendered from StyleGAN with some multi-latent gradient technique. So there are four different images, in fact, are generated at once and smoothed between each other, and translated with StarGAN with humanimal model. It shows like quite realistically looking cat. It doesn't follow all the bells and whistles of the source, but it still follows at least position and general like shape. It translates quite well. And if you take, for instance, way more complicated and crooked visual as a source, the result would be also a bit more funny, but it still, as we see, quite follows it quite well. No previous technique, no previous network could achieve such a result. So where are drawbacks, or what's the hidden troubles with it? Not as a real trouble, but as a quite serious time eater was that if we again look at the configuration, for instance, of the hyperparameters which we by which we control this network to run and to train, we see 4 lambda. The fourth one, lambda regularization, is not that really meaningful. So I was always leaving it like as it was set on the original repository on GitHub, like 1. But the other 3. Lambda DS diversity, lambda cycle for cycle reproduction, that is for resembling original source content, for keeping it similar to the source content, and lambda style, which was responsible for style reconstruction. These 3 parameters were really matter to explore, to change, and to see what's better. Because originally they were all set to 1, and if we train all of them as 1 with all the presets as an original repository, we would get a nice result if we again doing translation like this, where we have fixed layout, fixed shape, like face of the creature is always by center and stuff. Then we get like perfect image and so on. But what if we want to process some arbitrary video with arbitrary aspect, arbitrary resolution, etc. And again, when we talk about processing, visual processing, I want to be able to not just stylize it, like to make it look a bit different. I want to change the nature of the visual so that it would be taken, it would look like something totally different. And for that, just repainting it with different color or changing the brushes was not really really sufficient. We really needed something more, and those results couldn't be achieved with generic preset from the beginning. So I was here, for example, the test images from the trainings of the same dataset, some 8 various art graphics stuff with different presets of those coefficients, of those lambda parameters. Like first one is diversity, then cyclic content based, and then style based parameter which we should take into account, take care of. Those obviously should not differ a lot, otherwise we would we would have something maybe quite interesting, quite funny, but it wouldn't follow either or style or content quite totally. So here, for instance, in these examples are already, in fact, later experiments. I spent about 3 months, nearly full time, to get to these results. But so these are already foundings in the later times. This sheet, in this sheet, we see every column is a different domain, and every row is a different input image. So obviously we should see quite nice following the style of the style in this domain, which we see as well. But if we try to find some similarity on the row, where we should see some kind of micro shapes of the original, we don't see it here. So another attempt with the same parameters, but with higher resolution. I tried also to go 512 from 256 for doubling the resolution. But due to memory restrictions, I went from the batch size of 4 to batch size of 1. And here, as we see, we have totally lost content diversity. So the style is here. It's way more complex. More handled, but as far as we see the same images every now and then, it seems something went totally wrong. So I had to go back to like smaller size, smaller resolution, but bigger batch count, and also tried more diverse parameters. Again, sticking style lambda to 1, because as we all see in nearly all our examples, the styles are captured quite well. And if we see, for instance, this test sheet, we see that we can follow, in fact, some kind of similarity already. So it's good, but quite not enough. There should be we can recognize something in the from the content, but not much probably. And for 2 other tests which show us how well we can stylize content stuff with some references, I mean how well we can keep that reference. They were not of much interest for me because when you create some generative visuals, at least for me, I would more care about latent space animations to produce some smooth animation rather than to stick to some reference images. So I was mostly dropping this test. And for this test, when we check how well we can keep the content, how can we keep the cycle consistency that is going from the original image to the stylized one and back. This was also okay, but not really interesting because if we follow it well, it's good. But for most of all, we are interested in how well how nice imagery we can produce. And this is an example of the well-trained network, which I really used in the projects. Here we see that already we have quite similarity in the content. It's different enough so that it's different by kind of nature. It's felt differently. And here we see the same style on the column, so that should be okay. And if we check, for instance, the videos rendered for these with these networks, this was the first, where was too little of the content was kept, and we see that it doesn't look really. It looks funny, but we can't see anything reasonable here. Next one with higher resolution, as we, for instance, see. Let me stop for a moment. As we see here, instead of some kind of whatever abstract imagery, we see only this nice frame. That means that the network has lost the ability to capture anything from the content part from the source. So it starts drawing something based on the geometry of the frame as a whole, instead of the geometry of the content. So that means that could also produce quite funny effects, as I will show a bit later. But that's mostly for like kind of abstract art, which was not our goal. And then the next one, which is a bit better, if we see, if we try to see, we see there are something like more. Some shapes are more defined as previously. We see like this was probably someone's hand. But if you jump to the last one, we finally see the content kind of stylized or kind of processed, kind of transformed, where we can see the content kept in, and we see transformed in that or that way. So that was the parameter set which I was sticking to for quite a few projects, with some exceptions which I'll point out also later on. So okay, this also we may check very briefly with some also training process of that human-animal network. And when we see, for instance, such images where there is at least some image in the center where the content is, it's okay. That means that network is able to capture and to process, to transform at least something from the content. But if we see these frames, that means that the network is not good at that. And if for longer training we see that we're totally losing the content and the only frames are left, that means that we probably should not train it anymore. And in fact, indeed, the best time scale for training it was from 50K to 150K, like more than 200K iterations for training. Usually either we would be sticking to the content too close, going like style transfer way, or we would totally lose something. And yeah, for instance, if we have a look at the network trained with proper coefficient, we don't see these frames anymore, and we see that it processes the something within the image, tries to transform it into the so-called style image, in this case the animals. And here where our original content image on inference process was quite similar to the layout of the training samples from the training dataset, we see that it just nearly purely transformed it as it should have been, I guess, by the should have meant by the authors of this network, of this architecture. This approach, I mean, this set of lambdas like 3, 3, 3 with the regularization kept as 1 behaved well until I used it in a recent project for Year of Germany for some projection piece, where I was really impressed that from the really start of the training, the network was able to keep the content very well, but it proved not to be so good because later on with more training it was stick to the content too well. It again was only doing some recoloring and some really small changing in the shapes. So I had a first. I have taken finally the network trained just for 50K iterations instead of like 200 something, which I had trained it for. And second, I had to spoil a bit these parameters, so intentionally tweak them in a way so that the network would lose some of its ability to catch either style or the content pieces, so that it would be more funny, more art, more creative, I would say. Yeah, so this is, for instance, the same sample processed with the like best network with like best parameters, keeping as much content as possible. And this is, for instance, the same sample but handled with model trained with worse parameters. So we see it's a bit more creative, a bit more inventive, and a bit more fun. So yeah, that's I think quite enough for like training details. Let's see to some examples. What did I do? What have I done with all these thingies? So first was some experiment with again translating humans to animals, like direct approach, but with not with original model from the repositories from GitHub, but trained myself with bigger size, like 512 per 512, even with batch size equal to 1. This worked quite okay. Like obviously we don't see like properly handled when only human faces are handled, are processed into animal faces. But that wasn't the goal for me, and in general, as we saw pieces of realistically looking animals here, that worked pretty well. And also, Russian-speaking audience may really enjoy the soundtrack which I used.
По сторонам, оставайся такой, как есть, оставайся сама собой.
Okay, I think the organizers provided you with the links. I will send them the links to all the videos and stuff which I've used, so we don't spend time looking through every piece. Next case, next experiment was more about stylizing, like visual transformation in terms of nicely looking stuff. And this was also kind of technical demo, because all these like 2 minutes video with all these ever-changing styles and visuals were processed by a single network. So all the different styles, all the different domains, different looking portions depended on the provided latent vectors and provided style vectors which is animated on the input, and therefore got this styled animation on the output. So this is from a single model. Again, Russian-speaking audience, I guess, knows the original cartoon pretty well, so may like it as well. Okay, let's stop at this. And a few examples of misuse of this network. These are in fact screenshots or just samples from the, let's call it, badly trained networks, which obviously were totally losing content on the inference, and really were mixing up the styles, the domains sometimes. But one of the reasons of my excitement about this network was that even total failures and flaws of its work really looked nice and as an art on themselves. So I really enjoyed working with it because whatever you do, you either get like a controllable and predictable result and you're satisfied, or you get a totally uncontrollable and unpredictable result, which is still nice, and maybe it's even nicer than getting what you wanted, because you can get the things you would never wanted and would never get in this case. These are also screenshots from the which some of them I was showing already, and these, for instance, screenshots from videos which I made later on with already like properly on my opinion, for my goals, properly trained models, where every frame again looks as a kind of piece of art, and sometimes you can recognize the figures and shapes from the original footage, and sometimes you can't. You just see quite nice pieces of patterns or lines or whatever. It's just nice. But when it's animated, when these frames are just frames of the whole video, when properly selecting the original video, you can still follow the plot of it, even if the visual part is quite totally lost. So that's what I meant, in fact, by transforming the nature of the visuals. And let us finish with a piece which I made right before right before preparing this talk, where I combined the best models which I was preparing during all these like 3 months trip with StarGAN2. There is about 10 models, I guess, with specially selected nicely looking latent space areas, so that it was the network was using only those restricted latent spaces which I pre-selected and animated between them. And also I used one technique with another neural network which was creating masks for salient objects. So it looked at the frame and tried to draw the mask of the main object into it. And I used those neural generated masks to overlap differently styled, differently processed frames. So it is in fact one single video originally generated with StarGAN, as you probably can guess, and then processed like 10 times with 10 different models, overlapped with these masks, so there is kind of front piece and back piece on every frame. And then I manually cut selected a few most nicely looking fragments to either edit it into the final video. That was the only manual edit which I edited here. That's probably it. I made one more like heavy processing and longer pieces, like 12 minutes for the festival, which is now going on in Vladivostok. It's online, in fact, festival, Vladivostok, Berlin, Moscow. And for the moment when you are seeing this my talk, it's already was projected in Vladivostok, but will be repeated, and again translation will be repeated tomorrow, and I think it will be posted online as well. So hopefully you should be able to see it somewhere, sometime. These are the pieces of that projection. Okay, that's it for a moment. Thanks for listening.